in this problem, the key concept is to build the sign chart for a polynomial that's given to us in factored form. So in this case, the question here involves the polynomial x minus 2 times x minus 5. We're not going to pay attention to the rest of this question until after we've built our sign chart. The focus of the question is building the sign chart for this expression. So that's where we're going to spend our time, and then we'll come back and see how we actually answer that question from the sign chart. With our sign chart, we have our polynomial broken into factors. So this is our original polynomial, and these are the two factors that make it up. So for each of the factors, we can build a sign chart by first considering where the factor is equal to 0. So let's look at x minus 2, for example. When the way that x minus 2 is going to be equal to 0 is when x is 2. So on my number line, I'll label 2, and underneath the 2, I'm going to put a 0. Again, trying to keep this lined up. The dashed line there is just for me my own sanity to keep everything in line. So what I'm saying here is that when the value of x is 2, and you plug it into this expression, you get 0. So now I want to fill in on either side of this, not what values I get by plugging in other values of x, but whether the values I get are positive numbers or negative numbers. So I'll pick a number to the left of 2, and 0 is already labeled there, so that's a good choice. If I use x equals 0 in this expression, I'll have 0 minus 2, which is negative. So I'm not going to write negative 2, I'm just going to write negative. And what we know is that because these are polynomial factors, then if to the left of the 0 there is one minus sign, then they have to be all minus signs. The reason for that is this place we've marked as 0 is the only place that this factor could possibly change its sign. So since there are no other zeros out here, the factor can't possibly change again out in this direction. So once we figure out that there's a minus sign under 0, they all have to be minuses. There's no way for it to change it again. If I look to the right of 2, let's say this number here would be let's say 4. So this number right here would be x equals 4. If I plug x equals 4 into this, I would have 4 minus 2. And I can calculate that, but I don't really care what the value is. I only care that that's positive 4. And then by the same reasoning, all the values out on this side are going to be positive. So the second factor, the x minus 5 factor, is going to be 0, 1, 2, 3, 4, 5. So it's going to be 0 underneath the x equal 5 value. And again, I'll tie this together so it's clear what I'm talking about. And then once again, I need to look left and right of there to see whether I'm going to have minuses over here or pluses, and minuses over here or pluses. So once again, I'm going to come up to my x. I'm going to sample. So let's use 0 again. So that's an easy number to plug in. So to the left of 5, I have a number like x equals 0. When x equals 0, this is 0 minus 5, which is definitely a negative number. And once again, on one side of this 0 that I've written down, if I get a minus sign for one value, it's minus signs for all the values. And then finally, I need to test something over on this side. So x equals 6 would be the next number to the right of 5. When x equals 6, in this expression, I get a positive 1. And again, all I care about is that it's a positive number. So now I can put this together by using my rules for the way signed numbers get multiplied together. Remember, this is the product of these two factors. And so the value of this expression is going to be whatever the value of this first one is times the value of the second one. So when I do that, I'm going to have it out in this region, I'm going to have a negative number times a negative number. And anytime I have a negative times a negative, that's going to be positive. Where's my green? There it is. So any place out in this direction where I see a negative times a negative, that's going to be positive. I should have done this first, but I should have written in these two zeros, because again, I'm multiplying. So at 2, at x equals 2, I have a negative times 0. So that's definitely 0. And here I have when x is 5, I have 0 times a positive, so that's 0. So if I follow my rules for multiplication, in here, these numbers will be negative times positive, and that result is a negative. And then out here, I'll have positive times positive, and that result is positive. So that's my sign chart, and now I can go back to look at the actual question that was asked. It wants to know where that product, right, where this x minus 2 times x minus 5 is greater than 0. And so that's saying, when does the x minus 2 times x minus 5 sign chart have a plus sign? So I can grab my highlighter and I can shade the values of x that are underneath the plus sign. Now notice that the inequality here is strictly greater than. It's not greater than or equal to. So when I say a plus, I really mean a plus, not a plus or a 0. If this had been greater than or equal to, then I would want to know where do I have a plus or a 0. But I only have greater than, so that means I don't want to include the x's for which the expression is 0. And I indicate that on my sign chart by putting an open, unshaded circle around 2 and 5 to indicate that those are not to be included because the value of the product for those two numbers is 0, not positive. So the last step here is to turn this into interval notation, and interval notation is very thoughtfully designed to fit exactly with the shaded number line. What I mean by that is I can just go above my shaded number line and use my interval notation to express the same thing the shaded number line is expressing. So the way I'm reading this, I'm looking at my number line. This is shaded from forever this way up to 2, but it's an open circle. I'm not going to include 2. And that's what I mean by this. So minus infinity to 2, and I'm using the rounded paren to correspond to the open shading. Maybe that doesn't look unshaded to you. Let me just make it more obviously unshaded. And then similarly over here, this is shaded from 5 out forever this way, but not including 5. So from 5 to forever, but not including 5. So I say it here, 5 to forever, and I'm using the rounded paren to indicate I'm not including this. So the only difference if I had a greater than or equal to here is that I would have shaded in these dots, and I would have made these square brackets. So remember, the square brace is what we use to correspond to the shaded dot, which corresponds to putting the or equal to on the inequality.